Here we're looking at past paper questions that relate to A.1 Kinematics. And these questions have been taken from past papers in the years 2016 to 2022. There are a range of types of questions here. Quite a lot of multiple choice questions, which you'll of course find in paper 1A of your exams, and a few calculate style questions that you'd find in paper 2. A little note about the multiple choice questions in the previous specification. You weren't allowed a calculator in the previous specification for your multiple choice questions. And in your exams, you will be allowed a calculator. So you'll find that these multiple choice questions have very simple maths in them, but the concepts will be the same sort of concepts that you'll meet in your paper 1 section A. Without further ado, let's get going. Question 1. An aircraft is moving horizontally. A parachutist leaves the aircraft and a few seconds later opens her parachute. Which graph shows the variation of vertical speed with time for the parachutist from the time she leaves the aircraft until just before landing? So let's have a think about this. We'll draw a diagram. That's our aeroplane. Our parachutist is going to do this when she jumps out. But we've been told only to look at the vertical speed. So we're looking at projectile motion, horizontal projection, but we're actually only considering the vertical speed. And we know that the vertical speed of this parachutist will increase because she's falling under the influence of gravity. So we expect her speed, her vertical speed, to increase. Now, if you look at these graphs, C and D show the vertical speed decreasing. So we know it's not C or D. We can get rid of them straight away. What's going to happen is she's going to experience drag. So she will be moving downwards and her weight force will be like this and her upward force is drag. And as she gets faster, this drag force gets bigger and bigger. And eventually they'll balance each other, which means it'll have a constant speed. And both of these graphs are showing to the point where a constant speed is. What you've got to remember is that this lady is going to open her parachute, and when she opens her parachute, she will instantly decrease in speed, and that is the graph that shows this. So question 1A. Question 2. A car moves north at a constant speed of 3 meters per second for 20 seconds, and then east at a constant speed of 4 meters per second for 20 seconds also. What is the average speed of the car? Well, by telling you the directions of these speeds, they're tricking you because they don't care. They just want to know what the speed is, and the average speed of the car can be found with the equation total distance covered over total time. Okay, so the total distance covered here will be distance equals speed times time, so that'll be 60 meters. And the total distance covered here, that will be 80 meters. So the average speed is 140 divided by the total time, which is 20 plus 20, that's 40. That will be 3.5 meters per second, and our answer is 2C. Question 3. An object of weight W. Are you noticing that I'm drawing a diagram every time? And remember I said drawing a diagram is really important. In fact, if you don't draw a diagram, you're likely to miss something. Drawing a diagram at all times. An object of weight W is falling vertically at a constant speed. Whoop, whoop, whoop. When you see the word constant speed, you should be thinking the phrase balanced forces. Constant speed means balanced forces, which means that W has a balanced force up the way of drag, and it equals the weight force. What is the magnitude of the drag force on the object? It's the same as the weight force, so it's question 3C. Question 4. A tennis ball is hit with a racket from a point 1.5 meters above the floor. The ceiling is 8 meters above the floor. The initial velocity of the ball is 15 meters per second at 50 degrees to the horizontal. assume the air resistance is negligible. So this distance here, by very simple maths, is 6.5 meters. And question A, and this is a longer extended question which you'd find in paper 2, is determined whether the ball will hit the ceiling. Now, the ball will hit the ceiling if its maximum height is greater than 6.5 meters. So let's find what the maximum height of this ball will be. We are dealing with a projectile, so we use vertical and horizontal sides. On the vertical, we're interested in SUVAT equations, and on the horizontal, we're interested in the speed equals distance over time equation. But actually, we don't really care about horizontal because we're only interested in how high it's going to go. We know its initial speed is 15 sine 50 because we only want the vertical component of this final velocity. We know that the final speed at its maximum height, here, maximum height of the final speed is 0, so let's put 0. We've automatically chosen upwards as positive because we've given u, it's moving up the way, we've given that positive value. So that means acceleration, which is travelling in the other direction, is going to be negative, so minus 9.8. And t doesn't really matter to us. We can use the equation v squared equals u squared plus 2as, and we want to find out what s is. So let's plug in our data. 0 equals 15 sine 50 squared plus 2 times minus 9.8 times s. That's going to give us 0 equals 132.04 minus 19.6s. We're going to take the 132 over to this side, so minus 132.04 equals minus 19.6s, and we can work out s by dividing by 19.6. So s is equal to 6.7 meters. 6.7 is more than 6.5, so the ball will hit the ceiling. Question 5. Which of the following is a scalar quantity? Well, velocity is not, momentum is not, acceleration is not, but kinetic energy is. Energy is a scalar quantity. You just have to learn these quantities, folks. You've got to learn which is a scalar and which is a vector. Boring, but that's the way to do it. Question 6. An object is released from rest in the gravitational field of Earth. Air resistance is negligible. How far does the object move? So we want to know what s is. During the 4th second of its motion. During the 4th second means how far does it move between 3 and 4 seconds. So what we want to do is we want to find out how far it's travelled in 3 seconds, how far it's travelled in 4 seconds, and then subtract it to find this distance here. Okay, so for this we're going to use the SUVAT equations. It's a free-falling object in the gravitational field. Let's say downwards is positive. That means that acceleration is 10. Notice that I'm using 10 instead of 9.8 here, or 9.81. That's because calling it 10 or 9.8 is going to make no difference in terms of what these 4 answers are. So I can afford to approximate here. Doesn't matter if it's 9.8 or not. All right, so u is 0 because it's moved from rest. We want to know what the distance is after 3 seconds. So we're going to use s equals ut plus a half at squared. This goes to 0 because u is 0. So it's a half times 10 times 3 squared. So that's 5 times 9, which is 45 meters. So in 3 seconds, it travels 45 meters. In 4 seconds, it travels half times 10 times 4 squared. So that's 5 times 16, which is 80 meters. So it travels 80 meters in 4 seconds. So in the 4th second, it travels 80 minus 45, which is 35 meters. The answer is question 6C. Another one of these questions. Question 7, which is a vector quantity? Temperature is not, electric current is not. Pressure is in a gas, pressure can go any direction. Magnetic field definitely does have a direction, so I'm going to say 7D. Question 8. A ball is tossed vertically upwards with a speed of 5 meters per second. After how many seconds will the ball return to its initial position? So what it does is this, and there. It starts, and it's a SUVAT equation because it's an object in the Earth's gravitational field. Let's choose downwards as positive. Okay, so that means we can use 10 as downwards. We know that the initial speed is minus 5 because this is going up the way, so upwards is positive. How many seconds will the ball return to its initial position? When it gets back to here, S is equal to 0. Because it hasn't travelled any displacement. So we want to know the time. S equals ut plus a half at squared. 0 equals minus 5t plus a half times 10t squared. So 0 equals minus 5t plus 5t squared. Let's take this Sorry, you saw me make a mistake there. Easily done. Let's write that out again. 0 equals minus 5t plus 5t squared. Let's take that over to there. 5t equals 5t squared. They cancel. One of these cancels. So 1 equals t. The amount of time it takes to return to its initial position is 1. Question 8b. Question 9. A projectile is fired horizontally from the top of a cliff. The projectile hits the ground 4 seconds later at a distance of, at a distance of 2 kilometers from the base of the cliff. So that distance there is 2,000 meters, and it takes, that's distance horizontal, and it takes 4 seconds for that to happen. What is the height of the cliff? So we're looking at vertical motion. So vertical motion is SUVAT. We know that the vertical velocity is 0 because it's fired horizontally. Okay, so we can put 0 there. We want to know what the height of the cliff is. We know that if we take downwards as positive, the acceleration is equal to 10 meters per second squared. And we also know that it takes 4 seconds to hit the bottom. So actually we've got everything we need. S equals ut plus a half at squared. S equals a half times 10 times 4 squared, which is 5 times 16, which we did earlier, 80. So S, the height of the cliff, is 80 meters. Question 9b. Question 10. A glider is an aircraft with no engine. To be launched, a glider is uniformly accelerated from rest by a cable pulled by a motor that exerts a horizontal force on the glider throughout the launch. The glider reaches its launch speed of 27 meters per second after accelerating for 11 seconds. Assume that the glider moves horizontally until it leaves the ground. Calculate the total distance travelled by the glider before it leaves the ground. Because they've said uniformly accelerated, we know it's going in a straight line. We can use the equations of motion here. So write down the word SUVAT. We want to know the distance it travels, like the length of the runway. We know that it's being accelerated from rest. We know that its final speed is 27 meters per second. And we know that it takes 11 seconds for that to happen. So the equation we want to use is S equals U plus V over 2t. You can get that from your data booklet. So we got 0 plus 27 over 2 times 11, and that gives us 148 0.5 meters. Everything in the data is given to 3 significant figures, so you should give your answer to 3 significant figures. So S equals 149 meters. That's calculate question. You would find that in paper 2. Now, you would always find these as the start of a much longer question. It's actually very difficult to find a kinematics question that's very involved because they always tend to be the starter question. Question 11. An object is released from a stationary hot air balloon at height h above the ground. An identical object is released at height h above the ground from another balloon that is rising, speed v, at a constant speed. Okay, constant speed, that means something. Air resistance is negligible. What does not increase for the object released from the rising balloon? Oh, that's so easy. Acceleration is always, as we assume, within the gravitational field, 9.8 meters per second. It's the same for every object, so that was a very easy question in the end. Question 12. A river flows north. A boat crosses the river so that it only moves in the direction east of its starting point. What is the direction in which the boat must be steered? Okay, so the river's flowing north and the boat only moves in the direction east, so its resultant velocity is going that way. So what way must it be steered so that the resultant velocity is east? Now we must add 2 vectors tip to tail, and one of them has to be north, resulting in a velocity that's east. So the resultant vector is east. The vector that must be steered that adds up with north to get that resultant vector is there, and that gives us C. Question 12C. Question 13. An object is projected vertically upwards at time t equals 0. Air resistance is negligible. The object passes the same point above its starting position at times 2 and 8. So it looks like this. T equals 0 here. At this point here, at 2 seconds it hits that point, and it's way back down. At 8 seconds it hits that point. Now, if air resistance is negligible and it takes 2 seconds to get from here to here, it makes sense that it takes 2 seconds to get from here to here. So the whole time of the journey is 10 seconds. Let's see what we can do with that. We also know we're using a SUVAT equation because it's an object in freefall in the Earth's gravitational field. Let's choose upwards as positive and downwards as negative. So anything acting upwards is positive, anything acting downwards is negative. Well, we know that gravity is working downwards, so that'll be minus 10. The time of the whole journey is 10 seconds. We want to know what the initial speed is, and we know that the vertical displacement is 0 meters because it's travelled all the way up and travelled all the way back down, but vertically it's gone nowhere. So let's use S equals ut plus a half at squared. 0 equals u times 10 plus a half times minus 10 times 10 squared, which is 100. So we've got 0 equals 10u minus 500. Let's take that over. Minus 10u equals minus 500. So u equals 50 meters per second. The answer is A. Question 14. The velocities Vx and Vy of 2 boats X and Y are shown. Which arrow represents the direction of the vector Vx minus Vy? Do you remember that trick I taught you in math skills for A1 Kinematics, how to subtract vectors? Well, you subtract vectors by, instead of writing Vx minus Vy, you write Vx plus minus Vy. And what that means is you want to change the direction of Vy. So instead of thinking it goes that way, it now goes this way. Okay? So we want to add them tip to tail now. So we take Vx like this, and we add it tip to tail to Vy like this, and the resultant vector is from the start of Vx to the end of Vy, and we're looking at vector d. Question 15. An elastic climbing rope is tested by fixing one end of the rope to the top of a crane. The other end of the rope is connected to a block, which is initially at position A. The block is released from rest. The mass of the rope is negligible. The unextended length of the rope is 60 metres. From position A to position B, the block falls freely. At position B, the rope starts to extend. Calculate the speed of the block at position B. So between A and B, we know that the block falls freely. It will accelerate under the force of gravity in our Earth's gravitational field. So we're using the SUVAT equations. We want to know what the final velocity is. We know that the initial velocity is 0 metres per second. It's falling from rest. Let's choose downwards as positive. That means our acceleration due to gravity is 9.81 metres per second squared, and it falls a distance of 60 metres. You may notice that I flip between 9.8, 9.81 and 10 for gravity. Okay, I tend to use 10 in multiple choice questions, as I've explained before. In paper 2 questions, you really should use 9.81. Okay, so just you guys use 9.81. Okay, so we're going to use this equation here. V squared equals u squared plus 2as. V squared equals 0 squared plus 2 times 9.81 times 60, which gives us v squared equals 117.2, and v is equal to 34.3 meters per second. I think we should conduct a reasonableness check on this. Is it reasonable that a block would travel at 34.3 meters per second? Yes, it is. Is it reasonable that a block would travel at 1,177 meters per second? Well, no, it's not. Quite a lot of people might forget to square root the v, and if you forget to do that, fair enough, but you should always look at your answer and say, is it reasonable? Because if it's not reasonable, it means you've probably forgotten to do something. Okay, our answer here is 34.3. We've given it to 3 significant figures because the data at most is at 3 significant figures. Question 16. A truck has an initial speed of 20 meters per second. It decelerates at 4 meters per second. What is the distance taken by the truck to stop? We can see that this truck has a constant deceleration in a straight line. That means we can use the equations of motion. So we write down all our quantities in the equations of motion. That's SUVAT. We want to find out what the distance taken to stop is. Let's have a think about this truck. It's travelling in that direction, but the acceleration will be travelling in that direction. Let's say anything that way is positive and anything that way is negative. Okay? So the initial speed is 20 meters per second. The final speed will be 0 because it's come to a stop, and the acceleration will be minus 4 meters per second squared. The equation we'll want to use is v squared equals u squared plus 2as. Let's rearrange for s. V squared minus u squared over 2a equals s. Okay, the final speed is 0 minus the initial speed, which is 20 squared, over 2 times a, which is 2 times minus 4, equals s. So we have minus 400 over minus 8 gives us s equals 50 meters. The answer is C. Question 17. A runner starts from rest and accelerates at a constant rate throughout a race. Which graph shows the variation of speed v of the runner with the distance travelled? This question is telling us that there's a constant acceleration in a straight line. So we can deal with SUVAT equations here. We're looking at these 5 quantities. We know that the acceleration is constant, and we know that the initial speed is 0. If we can find a mathematical relationship between v and s, we can translate that mathematical relationship into a graphical form. Let's look at this equation here. V squared equals u squared plus 2as. U is 0, so what we find is v squared equals 2as. This is a constant. okay? So let's say v squared equals a constant ks. Now, on the y-axis in these graphs, we have v, so we could say y squared equals kx, and the s is on the x-axis. And mathematically, what would a y squared proportional to x graph look like? Well, we know that x equals y squared looks like this. And we know that these are linear graphs. There's no squared proportionalities in there. So it must be this one, question 17a. Question 18. A projectile is fired at an angle to the horizontal. Air resistance is negligible. The path of the projectile is shown below. And we've got a displacement graph here, which gives the magnitude of the horizontal component and the magnitude of the vertical component of velocity of the projectile between O and P. Well, easy. We know that the horizontal component of velocity is always constant, so we get rid of C and D, okay? And between O and P, the projectile is clearly falling back down towards the ground, which means its vertical component of velocity is increasing. The answer is A. This is about to get a bit trickier with the higher level question on this one. Question 19. A projectile is fired at an angle to the horizontal. The path of the projectile is shown. And can you see the projectile looks different from that in question 18? The projectile now includes air resistance. Which gives the magnitude of the horizontal component and the magnitude of the vertical component of velocity of the projectile between O and P. Right, the horizontal component does not stay constant anymore because air resistance slows it down horizontally. So we're looking between A and B, but we know that at O, the projectile has reached its maximum height. It's 0 at that stage in terms of the vertical velocity, and it is going to accelerate towards the ground. So our magnitude of the vertical component of velocity will increase. Our answer is A. Question 20. A skydiver is falling at terminal speed when she opens her parachute. So she's at terminal speed. That means there's balanced forces. I don't know if that's going to mean anything, but I'll draw that there just to remind me. What are the direction of her velocity vector and the direction of her acceleration vector before she reaches the new terminal speed? It's got nothing to do with forces. The velocity vector is always going to be downwards. At no stage will this lady be travelling back up, okay? But as the parachute opens, her acceleration will no longer be downwards because she decelerates very quickly, which means the force applied by her parachute causes a deceleration and acceleration in the opposite direction, making her slow down. So at that point, the acceleration vector is upwards, velocity vector is downwards, so the answer is 20C.
Since recording the original video, some people have struggled with question 22, 24 and 29. So I've added this part onto the tutorial just to help you, just in case it's the same problem that you're having. Question 22. A ball is thrown upwards at an angle to the horizontal. Let's draw that. A straight line, that's horizontal. Ball is thrown upwards and the angle is here. Air resistance is negligible. Which statement about the motion of the ball is correct? Before we go any further, let's just draw the trajectory of the ball. The ball will do this. A. The acceleration of the ball changes throughout its flight. Well, that's not true. The acceleration of the ball, because air resistance is negligible, the acceleration of the ball at all points is g, or 9.8 meters per second, downwards. So it's not that one. The velocity of the ball changes during its flight. Well, yes, the velocity changes. Let's put a tick next to that and make sure the other two are incorrect. The acceleration of the ball is 0 at the highest point. No, that's not true. The acceleration is always g, downwards. And finally, the velocity of the ball is 0 at its highest point. Now this is where a lot of people might struggle, because when the ball is released, it has a vertical component of velocity and it has a horizontal component of velocity, vh and that's V vertical. VH is constant, it doesn't change. So at the maximum point here, there still has velocity VH, which is the same as the velocity VH down there. VV does change. That the vertical velocity does change. It starts off at a maximum here at the start, and at this point at the maximum height, VV is equal to 0. So I think some people might look at this one and think that's correct, but it's not, because the velocity, horizontal velocity component is always constant. Just an aside here, if you're looking at a ball being thrown vertically upwards and then down, there's no horizontal element to that. So the V at the top is equal to 0 because there's no horizontal element. So if you're looking at a ball being thrown vertically upwards and then down, then the velocity at the top is 0. We're safe to say that. But as soon as we go to a projectile, then there's always a horizontal component of velocity, meaning the velocity at the top is not quite 0. The vertical velocity is. Question 24. A girl throws an object horizontally at time t equals 0. The air resistance can be ignored. At t equals 0.5 seconds, the object travels horizontally a distance x in meters, while it falls vertically through a distance y in meters. What is the initial velocity of the object and the vertical distance fallen? Let's draw a little diagram. We've got the cliff here. We've got the ball being thrown off the cliff like this, and it has an initial velocity of, we don't know, we want to find that out. The trajectory of the ball will look like this, and we want to find the initial velocity and the vertical distance. Well, the initial velocity is just a horizontal component of velocity. At the very start, the initial velocity doesn't have any vertical component yet because gravity hasn't had a chance to accelerate it. So our initial velocity is just going to be the horizontal velocities, which is V equals distance over time. We know it travels x divided by 0.5, which is equal to 2x. So the initial velocity is 2x, so it's C or D. To find the vertical distance fallen, we're going to have to take two calculations into account. First of all, we're looking at vertical velocity only, so we'll be using the SUVAT equations. And because the answers are given in terms of y, we first need to work out what y is. So we know that the initial velocity, vertical velocity of this object will be 0 meters per second. Don't really care about the final velocity. We know that the acceleration is 10 meters per second, and I'm using 10 because it's a multiple choice question. And our time here is 0.5 seconds. So S equals UT plus a half AT squared. Y, because S is equal to Y, distance fallen, is equal to, that goes to 0, a half times 10 times 0.5 squared. So that gives us 5 times 0.25. So 5 times 0.25, which gives us 1.25 y. So in half a second, that's how far the object has fallen. But the vertical distance fallen at t equals 1 second, we have to do the same. So we have to do s equals, don't know, u equals 0, v, don't care, a equals 10 meters per second squared, and t equals 1 second. So s equals a half at squared, s equals a half times 10 times 1 squared, s equals 5. And if we divide 5 divided by 1.25, that gives us 4. So the answer is 4y. 4y, our answer is D. Let me remind you that not all multiple choice questions will be easy. Some of them will have multiple steps. And multiple steps means you have to carry out more than one calculation. And in this case, it was 3 calculations. Some of them will just take time. Question 29. A large stone is dropped from a tall building. What is correct about the speed of the stone after 1 second? Now, there's something missing here. The thing that is missing here is ignore air resistance. It always says ignore air resistance. And in this case, it hasn't said ignore air resistance. So in this case, we have to consider air resistance. Let's draw. Got the building. Got a stone being dropped. It's only under the influence of vertical motion. We're looking at SUVAT equations, which means when there's no air resistance, this object will accelerate, or the rate of change of velocity will be 9.81 meters per second squared. However, that's always when we ignore air resistance. In this case, we're not ignoring the air resistance. Now, given that as that stone falls faster and faster, the force back upwards on it, the air resistance force, will be bigger and bigger. That tells us that the acceleration due to gravity, or the acceleration, which is the rate of change of velocity, will decrease. So what is correct about the speed of the stone? It's increasing because it's getting faster, so it's C or D. But it's at a decreasing rate because the acceleration is decreasing due to air resistance. So the answer is D.